In our search for alien worlds, we usually look for the Earth 2.0, places that are calm, blue, and safe. But the universe is rarely safe. In fact, it is mostly a violent, chaotic graveyard. Deep in the constellation of Cygnus, 670 light-years from Earth, there is a world that redefines the concept of extreme. It is a planet that is hotter than most stars. It is a world where the atmosphere is boiling away and where it rains molten iron in the dark. This is KELT-9b. For years, our models of planet formation said a gas giant like this shouldn't exist. It is simply too close to its host star. It is a ghost, living on borrowed time. But to understand why this planet is so terrifying, we cannot start with the planet itself. We have to start with the monster it orbits. Most exoplanets we discover orbit stars similar to our own sun. Calm, stable, G-type yellow dwarfs that have burned steadily for billions of years. But the star KELT-9 is a different beast entirely. It is a massive A-type blue star, a stellar engine running on overdrive. If you were to place it next to our sun, the contrast would be terrifying. Our sun would look like a flickering match held up against a stadium floodlight. KELT-9 is 2.5 times more massive and burns at a scorching 10,000 degrees Celsius, nearly twice the temperature of the sun. But it isn't just hot, it is young, volatile, and incredibly violent. The most striking feature of KELT-9 is its rotation. Our sun is a leisurely dancer, taking about 25 days to complete a single rotation. KELT-9 is a spinning top out of control, completing a full rotation in just 16 hours. This extreme velocity has physical consequences that defy our usual mental image of a star. The centrifugal force is so intense that it is physically pulling the star apart at the seams. It isn't a perfect sphere, it is an oblate spheroid. It is squashed at the poles and bulges violently at the equator, looking less like a ball and more like a flattened, glowing M&M. This distortion creates a rare phenomenon known as gravity darkening. Because the equator bulges out, it is further away from the dense nuclear core, making it cooler and dimmer. The poles, however, are compressed closer to the core, making them blindingly bright and intensely hot. It is a star with a temperature gradient on its own surface, a spinning, blue-white furnace blasting out a lethal torrent of high-energy ultraviolet radiation. The habitable zone for a star this hot would be roughly 6 to 8 astronomical units, somewhere past the orbit of Jupiter in our own system. But the planet we are looking at isn't out there in the safety of the dark. It is right in the monster's mouth. Orbiting this distorted blue giant is KELT-9b. It sits so close to the star that its orbit defies logic. It completes a full year, a complete circle around its star in less than 36 hours. To put that in perspective, it is 10 times closer to its star than Mercury is to the Sun. It is skirting the very edge of the Roche limit, the invisible line where the star's gravity would simply rip the planet into dust. But the orbit isn't just close, it is geometrically violent. In our solar system, planets orbit roughly in line with the sun's equator, like a flat disk. KELT-9b ignores this rule. It possesses a highly inclined, polar orbit that is almost perfectly perpendicular to the star's equator. Instead of circling the middle, it swings vertically over the star's poles. This trajectory forces the planet to pass directly over the hottest, brightest regions of the star, those blinding white poles mentioned earlier, subjecting it to a fluctuating and punishing radiation bath that no normal planet could withstand. At this distance, the relationship is purely parasitic. KELT-9b is tidally locked. One side is trapped in an eternal, blistering noon, while the other is frozen in an everlasting midnight. On the day side, the view would be apocalyptic. The star doesn't just sit in the sky, it consumes it. KELT-9 would appear 70 times larger than the sun looks from Earth, hanging motionless, a blinding, heat-radiating ceiling that covers a vast portion of the sky. This proximity has ruined the planet's structure. KELT-9b is heavy, about 3 times the mass of Jupiter. Under normal physics, a planet with this much mass should be pulled by its own gravity into a tight, dense ball. But KELT-9b is not dense. It is grotesquely bloated. The intense heat from the star acts like a pump. The ultraviolet radiation punches into the atmosphere, energizing the gas particles and forcing them to move frantically. This kinetic energy pushes the atmosphere outward, fighting against the planet's gravity. If you put them side by side, KELT-9b would be nearly twice the physical size of Jupiter, yet it has the density of styrofoam. It is like a hot air balloon that has been overinflated to the point of bursting. It glows with a dim, sinister red heat on its night side and a blinding incandescent white on its day side. It is the fluffiest, hottest, and most tortured gas giant we have ever seen. On the surface, the temperature reaches a staggering 4,300 degrees Celsius. This is not just hot for a planet, this is hotter than many red dwarf stars in our galaxy. At this thermal threshold, something fundamental changes. The atmosphere stops acting like a planetary gas and starts acting like a stellar atmosphere. It is a world that has lost its identity, trapped in a transition between a planet and a star. Let's talk about that heat. On the day side of KELT-9b, the temperature hits 4,300 degrees Celsius. This is hotter than the surface of the star Proxima Centauri. At these temperatures, the atmosphere enters a state that we rarely see on a planet. It becomes a molecular slaughterhouse. On a normal gas giant, hydrogen atoms hold hands to form H2 molecules, but on KELT-9b, the radiant energy is so violent that these bonds are smashed. The hydrogen molecules are ripped apart into individual atoms. The atmosphere isn't gas, it is plasma. This creates a bizarre cycle. As winds blast this atomic soup towards the night side, which is a cooler 2,000 degrees, the atoms calm down. They recombine into molecules. But as soon as the wind carries them back to the day side, snap, they are torn apart again. The planet is trapped in an endless loop of destruction and reconstruction. But this molecular chaos is happening inside an environment that defies gravity. The orbit of KELT-9b is not just close, it is geometrically wrong. The planet isn't orbiting the way it should, and that is causing the star to look distorted. When scientists from the universities of Bern and Geneva analyzed the light passing through KELT-9b's atmosphere, they found fingerprints that shouldn't be there. They found iron, they found titanium. On Earth, these are solid metals we use to build skyscrapers and ships. On KELT-9b, they are vapors. The heat is so extreme that iron floats in the sky like oxygen does on Earth. But remember the temperature difference? The day side is 4,300 degrees, but the night side is much cooler. Theoretical models suggest a terrifying weather system. As the iron vapor rides the supersonic winds to the night side, it hits the cold front. The iron cools, it condenses, it creates clouds of heavy metal, and then it rains. Imagine a storm where the raindrops are molten iron and titanium falling from a pitch-black sky into a glowing, pressurized abyss. This rain likely evaporates before it ever hits the deep core, cycling back up to be vaporized again. It is a world of heavy metal storms driven by a star that is trying to destroy it. The relentless ultraviolet light from the star acts like a cosmic sandblaster, but the process is far more violent than simple erosion. It is a planetary hemorrhage, the radiation stripping away the planet's atmosphere at a staggering rate of nearly 10 million tons every second. If you could see KELT-9b with human eyes, it might look like a comet. It is trailing a massive tail of hydrogen gas behind it, a bleeding wound in space. Yet the planet is massive enough to survive this evaporation for nearly 1 billion years, but it doesn't have 1 billion years. Its fate is tied to the ticking clock of its host. KELT-9 is living fast and dying young. Soon, in cosmic terms, the star will exhaust its hydrogen fuel and begin its death throes. It will swell outward, transforming into a red giant. The boundary of the star will expand past the planet's orbit, and KELT-9b will be swallowed whole, vaporizing inside the very monster that created it. This planet is a rare, fleeting moment in the galaxy. It is a laboratory of the extreme, showing us physics pushed to the absolute breaking point. It reminds us that for every Earth-like paradise, there is a hellscape waiting in the dark. KELT-9b is a planet that shouldn't exist, orbiting a star that is killing it, raining iron in the dark. And that's what makes it beautiful.